Get ready for a mind-blowing secret about our planet. You might think oxygen makes life possible, but surprisingly, it's the other way around. Life creates oxygen. That's right, our atmosphere is packed with oxygen because of all the living things that call Earth home. Scientists even use high levels of oxygen as a cosmic signal to search for signs of life beyond our world, like on distant planets. But here's the twist. This rule doesn't apply to Mars. Yet another reason why the red planet remains an enigma. Buckle up for a Martian mystery. On the red planet, something weird is going on with oxygen. It seems to be showing up and then disappearing without warning. This has scientists stumped, as they're trying to figure out what unknown force could be adding and then taking away this gas from Mars' atmosphere. Unlike Earth, where we've got a comfy 21% oxygen level, Mars is a barren wasteland with just 0.174% oxygen and an astonishing 95% carbon dioxide. The Martian air mix also includes some nitrogen, argon, and other gases. But here's the kicker: our home planet's atmosphere is super stable all year round, whereas Mars' chemical elements seem to be playing a much wilder game. Will this atmospheric puzzle push us to rethink our Mars exploration plans? Stay tuned for more Martian surprises. Get ready to experience Mars' extreme seasons. On the red planet, winter brings a crazy change. Carbon dioxide, making up almost all of Mars' air, starts freezing into massive dry ice caps at the poles. This causes air pressure to plummet globally, and a massive air swap happens between hemispheres. When spring arrives and that dry ice melts, the opposite effect hits. Air pressure soars. Eventually, the atmosphere balances out. But here's what's really wild: despite these dramatic seasonal shifts, the overall mix of Martian gases has stayed steady over the past 6 years. Except for 2 weird cases, oxygen and methane levels are behaving differently than expected. What's causing this Martian mystery? Let's dive deeper into this Martian enigma. NASA's own Melissa Trainor, a planetary scientist specializing in astrobiology at the Goddard Space Flight Center, has uncovered some mind-blowing oxygen trends on Mars. It turns out that as spring and summer hit, oxygen levels skyrocket by up to 30%, only to drop back down come autumn. On Earth, such a drastic increase would have led to a very different planet. But for Mars, this is just another day. So, what's behind this mysterious oxygen release? One thing's clear: there's an unknown source on the red planet that's pumping out extra O2 into its atmosphere. And it's not alone. Methane levels are also behaving strangely, spiking by 60% in summer and then vanishing as winter arrives. What could be causing these Martian gas giants? Let's travel back to 2014, a pivotal moment in Mars research. That's when scientists made an exciting discovery about manganese oxide in Martian rocks. Now, you might be wondering, what's the big deal about manganese? Well, it's super resistant to oxidation, making it tough for oxygen to break it down. This finding raised some serious questions. Could there be another way that oxygen is interacting with Mars' environment? Maybe instead of living organisms, the source of this Martian mystery gas is something entirely different. Think of it like a cosmic puzzle, and we're just starting to uncover its pieces. Stay tuned as we keep digging into the secrets of our red planet neighbor. Hold up, let's break this down. If manganese oxide is key, we need oxygen on Mars' surface. But here's the catch: there just isn't enough oxygen in the Martian air for most of the time. So where does all that oxygen end up? The answer might surprise you: it's mostly found in water. But wait, there's a catch. This water is way down deep beneath the ice. Since Mars is crazy cold, with temperatures averaging -60, 2 degrees Celsius or -80 Fahrenheit. And don't even get me started on liquid water flows. They're super rare on Mars. Mostly, we see it as either frozen ice or just floating around in the air. But what if I told you there's one exception? Think about this: when you add a bit of salt to water and take it outside on a chilly day, something cool happens. The mixture can actually stay liquid even in freezing temperatures, a phenomenon scientists are super interested in, especially when it comes to our Martian friend. Alright, let's dive back in. So, we've got our manganese oxide mystery and the need for oxygen. But here's where things get really interesting. Water on Mars freezes much slower when you add salt to it. Like what happens when you mix sea salt with ice at home, but on a much bigger scale. If you live near the coast, you might have noticed that ocean water doesn't completely freeze at 0 degrees Celsius or 32 degrees Fahrenheit. Instead, it takes a chillier temperature of -1.8 degrees Celsius or 28.76 degrees Fahrenheit for sea ice to form. And guess what? Mars is packed with all sorts of salts, including magnesium and calcium, that can supercharge this effect. These salts are like natural icebreakers, lowering the freezing point of water down to a bone-chilling -80 degrees Celsius or -112 degrees Fahrenheit. Now imagine these saltwater brines seeping into Martian ice. It's like an oxygen tug-of-war in there, with the cold trying to freeze everything solid and the salts working against it to keep things liquid, even at temperatures that would instantly turn regular water into ice. So we've got this intense battle going on inside these salty Martian brines. It's like a game of tug-of-war between oxygen and the cold. The more salt that gets mixed in, the less oxygen the water can hold on to. But at the same time, when temperatures drop even lower, the water becomes super efficient at grabbing onto oxygen. It's a delicate dance where salts are constantly pushing out dissolved gas, and the cold is pulling it back in. Now you might be wondering how all this affects our trusty manganese friend alone. Well, when it gets added to these brine mixtures, it gets oxidized in an instant. And here's what's really cool: researchers think that even though these salty solutions can get pretty toxic, they actually have enough oxygen to support not just basic bacteria, but maybe even more complex life forms like sponges. But don't worry if you're imagining a Martian ecosystem teeming with life. Things are actually much harsher than that. These brines that form from percolates are incredibly deadly, and scientists from the University of Edinburgh have shown that they can kill off Earth bacteria twice as fast when exposed to UV radiation compared to the radiation alone. It's like a toxic cocktail that's straight out of science fiction. So, while these toxic brines might sound like they'd make life on Mars impossible, there's actually a twist. This process could actually create environments that support life. Cosmic radiation can break down the salty mix into other compounds, which in turn release oxygen. But here's the catch: it happens at an incredibly slow pace, and scientists think it couldn't possibly be responsible for the massive oxygen spike they've observed on Mars. Now we're left wondering what else could be behind this mystery. And if you've ever put antibacterial ointment on a cut or scrape, you might have just guessed correctly. It's none other than hydrogen peroxide. Yep. Researchers are now thinking that hydrogen peroxide could be the missing piece of the puzzle, enriching Mars' atmosphere with oxygen in a way that salt water alone just can't explain. Here's how we break it down on Mars. Hydrogen peroxide isn't just some ointment you put on a scrape. It's actually floating around in the air as a gas. And guess what? It's produced when sunlight breaks down carbon dioxide and water vapor. But here's where things get cool. When this hydrogen peroxide combines with underground water seeping onto the Martian surface, it becomes an ultra-powerful germ killer that destroys bacteria way more effectively than just UV radiation alone. This potent mix can even sink deep into the Martian soil, up to 3 meters or about 10 feet, creating a hidden stash of oxygen. And the best part, this underground oxygen can slowly make its way back to the atmosphere over a whopping 10 years. Now, this idea might sound far out, but it's actually been supported by some radical experiments from way back in the 1970s. Now let's dive into what actually happened when those brave Viking spacecraft took Martian soil samples. They essentially brewed up an oxygen bonanza by humidifying the dirt. But here's the catch: it all went down in a lab environment that was way warmer than Mars' chilly average surface temperature. The question is, would this same trick work if we were to give the Martian soil a steady supply of water and the right conditions? It turns out, even with those perfect conditions, the oxygen levels wouldn't skyrocket like scientists expected. Not even close. They're talking 30% oxygen in the atmosphere, but that's just not happening. So what gives? Scientists are scratching their heads, and one leading expert, Professor Sushil Atreya from the University of Michigan, is looking to some seriously high-energy players for answers. Those cosmic particles zipping through space might hold a key to unlocking Mars' mysterious oxygen puzzle. You've got to check out what Planetary scientist Bethany Ehlman from Caltech is saying about Mars' soil. It's way more reactive than anything we're used on Earth, and the Martian surface is basically a treasure trove of iron-rich and sulfur-rich minerals, which aren't found anywhere else in our solar system. That tells us that these materials have some seriously unique properties or ways of reacting that don't happen here on our planet. So, what's behind Mars' oxygen mystery? Unfortunately, we still don't have an answer, and it looks like it might be a major hurdle for future space explorers. A constantly shifting atmosphere is not ideal for trying to establish life on the red planet. Can you imagine setting up camp only to find the air changing dramatically around you? It's yet another reason why Mars remains such a fascinating, yet tough, place to study and explore. You know, life on our planet didn't exactly start at surface level. Tiny living things first made their mark in hidden environments where they could evolve and adapt. Over time, these early organisms emerged onto land, paving the way for us humans to take our first steps. And who knows, maybe one day, it'll be Martians taking their own strides. So, can we transform Mars into a place where we can walk freely without suits and breathe in that crimson air? We'd love to hear your thoughts. Hit that comment button and let's chat. If you enjoyed this video, be sure to subscribe for more epic content, tap the bell to stay updated on our latest episodes, and give us a thumbs up if you liked it. Don't forget to share this video with your friends. Let's keep the conversation going. I think there might be some confusion. Since we started fresh, I didn't include any previous content or context in my response. The conversation was about rewriting